All right, our next parent function is, some people wouldn't separate this off as its own thing, but I think it's going to be important for us. We're going to call this the square reciprocal. Our basic notation is going to look like f of x is 1 over x squared, or we could call that x to the negative 2. Now that we've done our exponential unit, we know what that looks like. And really this is virtually the same. We'll say it's similar to 1 over x to the n, where n is any even number. So this graph will look like the same as 1 over x to the 4th and 1 over x to the 6th. And the reality is that our reciprocal function of just 1 over x looks very similar to 1 over x cubed and 1 over x to the 5th and 1 over x to the 7th. And that's going to be important for us to remember down the road. Okay. So the arrow diagram for this, we'll symbolize it this way. And we want to talk about end behavior here. So negative infinity, we'll see what's going on at negative 1 and at 0 and at 1, and then at positive infinity. That should be enough points to get a sense of what's going on here. So at negative infinity, this is approaching 0. So as I go way out to the negative x-axis, my outputs are getting very, very close to 0. If I put a negative 1 in, negative 1 squared is positive 1. 1 over 1 just gives me a 1 out. If I try to put a 0 in, I get division by 0. I'm going to write that as undefined here. I have at times, drawn this to indicate what's going on there. I'm fine with either one of those. It's just you got to pick something that's that you're going to remember what's going on. When we put a 1 in, we get a 1 out. And as we go to infinity, 1 divided by a gigantic number squared, we break that 1 up into tons and tons of parts. Each part is worth virtually nothing. Okay. So graphically, what I have going on here, this thing in the middle here is what we call a vertical asymptote. This is there to indicate that there is no output whatsoever if you try to put a 0 in as an input. And so we absolutely cannot have that in there. We have horizontal asymptotes up here. Anytime that our end behavior is described by a number, we call that a horizontal asymptote. So that's happening there, and it is also happening down here. Okay? And so that horizontal asymptote at 0 indicates that graphically we should put a dotted line here, or it's really end behavior, so the middle part of it is irrelevant. Okay? The vertical asymptote, we're going to put a dotted line right here on top of the y-axis. Okay? Our points, the important points that we're going to need number-wise then are here, here, and here at negative 1 and 1 on the x-axis and at positive 1 on the y-axis. And so the points, I'll do this, I guess, in red. I've got a point at negative 1, 1 and at 1, 1. And this starts down here close to the axis, goes up here, and then it cannot touch that point, so it goes up like that. And unlike the odd reciprocal function, just the 1 over x, this one stays always positive. So on the other side, it's like a mirror image across the y-axis. Okay? There's nothing going on down below here, so we can describe the domain and the range here. My domain, I can't say it's all real numbers because I can't put the 0 in. So I can describe that as it's all of the x's, but x cannot equal 0. And I could describe that in interval notation, inequality notation is the easiest way to do that, though. And the outputs that I can get any positive y value. I can't get the negatives, and I can't get 0. So I'm going to describe this range as y values that are greater than 0. Okay. The other special note that I want to throw in here, and then we'll use our description of asymptotes here in a second as well. But you'll see this show up sometimes when they talk about, if they use the word, it varies inversely, which means this variable is going to go into the denominator as the square, in this case, because it was squared, and they'll say some other things in there. But that's a phrase that causes this function to show up. Our in-behavior description, we can say that as x approaches either positive or negative infinity, our outputs are going to approach 0. So that's my description of the end behavior, and I can describe what's going on around the vertical asymptote by saying as my x values get close to 0, because I can't make them 0, the f of x values are heading toward positive infinity. I think that's what we need here for our square reciprocal notes.